Okay, good day to everyone. I'll be continuing my discussion regarding with the application of Coulombs Law in problem solving. But before we proceed in that discussion, let us have a short recap regarding with the Coulombs Law. The Coulomb's law states to us that the electric force between two-point charges or collection of charges is directly proportional to the product of its charge, while it is inversely proportional to the square of their separation distance. Okay, take note that the SI unit that we are going to use with electric force would be Newton, for the charges would be Coulomb, and the separation distance to be in terms of meters. Okay, so K here is called the Coulomb's constant or the proportionality constant K. That is approximately 9 times 10 to the 9 Newton times meter squared per Coulomb squared. Okay, so that is the value that we are going to use throughout the discussion. Okay, so the implication of Coulomb's law in dealing with charges is very important because this is the majority uh, thing, is the major equation that we are going to use. Okay, aside from the vector analysis that you have discussed in the previous semester. Okay, so remember that charges needs to be in coulombs, and if charges are not being given, the values of the charges is not given, while the nature of charges is being stated, such as it is an electron or proton, you can just use the elementary charge, which is the smallest unit of charge, having a value of 1.6 times 10 to the negative 19 coulomb. Okay, so for today's discussion, we are going to deal with how are we going to denote electric forces being experienced by point charges. Okay, so you have here a two uh, charge, positive point charge, Q1 and Q2. So we all know that when the charges are of the same sign, the electric force they experience are repulsive. Okay, so I want you to observe this charge Q1. Okay, this charge Q1 experienced a repulsive force due to Q2, right? Because the presence of Q2, okay, makes it to be repulsive with some separation distance r. Okay, so how do we denote that electric force being experienced by Q1 due to Q2? We can denote it as F21. Okay, meaning to say this is the force, okay, being experienced by Q1 due to 2. Okay, or force, electric force of 2, charge Q2 on 1. Okay, so I hope that is clear to everyone. While in this part, this charge Q2, they will experience some electric force, a repulsive force due to the presence of Q1, right? That is why it is denoted as F1, 2. So kung sino yung nakaka-experience ng force, siya lagi yung nasa dulo na subscript sa ating notation. Okay, so for this case, we have F21 dahil si 1 yung naka-experience ng electric force. Okay, in this part naman, si 2 yung nasa dulong subscript because siya yung naka-experience ng electric force due to Q1. Okay, so that is the thing that we need to consider in dealing or solving electrical forces. Okay, well, the R12 here just represents the direction of the uh, repulsive force. Okay, but it doesn't mean that it is directed here. It is just denoted somehow like this. Okay, R1, 2. So remember, unit vector, it is just a vector having a magnitude of 1. Okay, that is uh, the purpose in pointing direction. Okay, so electrical forces also obey Newton's third law. So when do we observe Newton's third law in electric forces? We can observe this when the forces, okay, are equal in magnitude. Okay, kailan ba nangyayari na equal ang magnitude ang F21 at F12? Pagka yung magnitude ni Q1 at ni Q2 ay pareho. Okay? Pag same sila na magnitude, therefore, both forces, both electrical forces are just the same. Okay? Therefore, it will uh, fit into the concept of Newton's third law wherein the action and reaction pair, the two forces are equal in magnitude, but acting in opposite directions. Okay, that is why the force on Q1 is equal in magnitude and opposite in direction to the force on Q2. So we can denote it as F21 is equivalent to negative F12. Okay, so with like signs for the charges, the product Q1, Q2 is positive and the force is said to be repulsive. Okay, that is very clear to us. Pag pareho ng sign, okay, matik, ang kanilang product is positive. Okay? So another thing is that how about if we have attractive forces? Okay? So in the previous example, we have both positive charges, while in this example is that we have unlike charges, Q1 and Q2. Q1 here is a positive one, while Q2 is a negative one. Thus, it will experience again an electric force due to the presence of each charges. Okay? So let's consider this Q1. It experiences an attractive force due to the presence of Q2. Tama, no? Because they are unlike charges. Okay, so ma-attract si Q1 papunta kay Q2. That's why we can denote it as F21. Okay? F21. So again, pansinin niyo ulit yung subscript. Kung sino yung naka-experience ng force, okay, siya yung nasa dulo na ah, subscript. Okay? And kung sino yung naka-influence ng force na yon, is siya yung nandoon sa pinakaunahan ng subscript. That is why F21. Same thing with this uh, Q2, we have an attractive force F1, 2. Okay, meaning to say that this is the force on 1 due to force of 1 on 2. Okay? Or force on 2 due to 1. Okay? So I think malinaw naman sa atin iyon. So when these 2-point charges are separated by some distance r and they are uh, opposite in sign, the tendency of the electric forces would be in attractive case. Okay? So the sign of the product of Q1, Q2 gives the relative direction of the force between Q1 and Q2. However, in Coulombs law, we are just using the absolute value na equation. Okay? That is why you must be careful in dealing where is the direction of these forces. Okay? So the absolute direction is determined by the actual location of charges. Okay, later on we can specify okay what would be these directions na ating pinag-uusapan. Okay. So in dealing with electrostatics, we are not just having these two charges. Okay, there are cases na three charges yan, okay, four charges. Meron namang mga material that is composed of several charges. Because we all know that these charges are present in a specific material na hindi lang naman sila dalawa. Okay? Multiple charges ito. Okay, so how do we then utilize Coulomb's law when we are dealing with multiple charges? So the resultant force on any one charge equals the vector sum of the forces exerted by the other individual charges that are present. So what does it mean? It means that when you are dealing with one charge due to the presence of several charges, makukuha mo raw yung resultant force being experienced by that charge by getting the vector sum of all the forces. Okay? You need to determine the interaction of that charge to one another charge and to the another charge and to the other charges located near that specified charge. Okay? So remember that we need to add the forces as vectors. Okay, they are not the same with the scalars na you can just directly add them. Okay, because we all know that forces is a vector quantity. We need to specify the direction. We need to consider the direction. Okay, so the resultant force, okay, let's say for example, our concern is the charge Q1, okay, due to the presence of several charges. How do we find the resultant force? The resultant force on Q1 is just the vector sum of all the forces exerted on it by other charges. Meaning to say, isa-isa. Okay? Kukunin mo bawat forces experience on Q1 due to the several charges present sa kanya. Okay? That is why, if you want to find the resultant force on Q1, it is denoted mathematically as F1 is equal to the vector sum of F21, okay, plus F31 plus F41. Okay, if you have several charges, you have F51, F61, and up to F sub n. Okay? Yan yung sinasabi natin na multiple charges. So, naalala ba natin kung anong tawag natin dito? It is called as the superposition principle of adding forces. Okay, or adding vectors. So I hope naalala pa natin yan. Okay, and you need to clearly see here in the equation, okay, na si 1 yung nasa dulo ng mga subscript. Dahil siya nga yung concern mo na charge. Okay, siya yung iyong frame of reference. So let's consider this particular example. So where do you think the resultant force is equivalent into zero in the setup of these charges? So you have here charge Q1, charge Q2, and charge Q3. Okay? So we all know that the resultant force is the net force. Okay, yan na yung pinaka-net force being experienced by a particular charge due to several charges, no, or a particular charge. So for this case, we can say that the magnitudes of the individual forces will be uh, equal. Okay, so this F23, if you will notice, and F13, okay, their directions are opposite. Okay, binigay naman na sa atin dito. Okay, na sila ay opposite. Okay, we don't know the values of these charges. Okay, it is just being specified here. So if we can notice, the length of the vector F23 and F13 are just the same. Meaning to say, if they are the same, they just canceled out. Okay, that is why the net force being experienced by this charge Q3 is just 0. Okay, ganun kasimple. Whenever the charge experienced by a particular charge is equal and acting in opposite direction, the net force or the net resultant electric force is just equivalent into 0. Okay? How about if we have this kind of setup? Okay? Charge being suspended by some string or sabi nating tali, no? So they are both positive. Okay, so kung sila ay parehong positive, ang tendency nila is mag-repel sila sa isa't isa. Okay, giving us this setup. And they are said to be in equilibrium, creating an angle theta here and the same thing theta here. Okay, so this is the length L for this setup and length L also for this. So the distance between the uh, center, okay, of this uh, electric forces is equivalent to A. Okay, meaning to say the distance from Q up to Q here is 2A. Tama no? Not A squared. Okay, it must be 2A. So how do we then see the significance of this setup? Okay, we can see that in this kind of setup, you can actually get the resultant force by utilizing the Coulombs Law. Okay, kaya nating makuha because there is an interaction between this Q due to this Q and interaction of this Q due to this Q. Okay, that is why dealing with one part of the charges, okay, na binigay kanina sa atin, this is the free body diagram of that setup. So it experiences some tensional force due to the rope. Tama, no? This is the T. And we have here the mass of this charge. Okay, let's say this is a proton. Okay? So meron siyang mg. Okay, at the same time, nakaka-experience siya ng repulsive force due to the presence of this another charge. Okay, kaya meron siyang ganito. Okay? So by means of this free body diagram, you would now be able to find this electric force. Okay? So binigay na rin sa atin yung components ng tension. So sa X, ang kanyang component is T sine theta, while in the Y is T cosine theta. Okay? Now the task here is solve for Q. Okay, so maybe this is just a working assignment na lang sa inyo, how to find Q. Okay, paano mo masosolve si Q dito? Okay, so gamitin natin yung component method ng vectors. Okay, so you need to work on it, how to solve for this Q. Now, I want to give another example regarding the utilization of Coulombs law sa iba-ibang problem solving. So let us consider first this example. Okay, you have 2-point charges, Q1, which is equivalent to 25 nanocoulomb, and it is a positive one. And then you have Q2, okay, which is negative 75 nanocoulomb, okay, and a negative one. So they are unlike charges. Tama, no? So the tendency is that they would attract to each other, no? And being separated by a distance r is 3 centimeter. Okay? Find the magnitude and direction of the electric force that Q1 exerts on Q2 and that Q2 exerts on Q1. Okay, so we are going to find these individual electric forces. But before we proceed in the solving, kailangan ma-visualize muna natin ano ba yung itsura ng ating problem. So sabi niya dito, meron daw tayong dalawang point charges. Okay, so let us try to sketch. Okay, so this is our setup. Yan, meron tayong 2-point charges. Yung isa daw ay positive. Okay, so sabihin natin na ito ang positive. Tapos yung isa naman is negative. Alright? So this is automatically the 25 nanocoulomb, while this part is the negative 75 nanocoulomb. So let us just try to specify. Okay, this is the positive 25 nanocoulomb. Okay, and then we have here the negative 75. Okay, parang grades mo lang, no? Negative na, 75 pa. Alright. Yeah. So we all know that they tend to experience repulsive force. We forgot the separation distance to be uh, 3 centimeters. Okay, so this is the separation distance R. Okay, so this is the separation distance R for this setup. Okay, so ang unang-unang step pag tayo ay nagsosolve ng electric forces, we must first sketch the problem. Okay, or make a simple illustration regarding with the problem. Hindi ka agad-agad mag-compute. Okay, so ganyan yung ating setup. The next thing na kailangan nating makita is the direction of the electric forces being experienced by individual charges due to the presence of each charges. Okay, so let us first try to examine okay, the charge Q1 here, positive 1. The tendency of this Q1, okay, is ma-attract siya dito kay negative. Tama? Dahil siya ay positive, ang tendency niya is ma-attract siya papunta kay negative. That's why you need to sketch, okay, some arrow, okay, oriented like that. Okay? And at the same time, this negative charge will also experience an attractive force, okay, papunta dito sa ating positive charge object. Okay, so na-specify na natin yung direction, tama? So, kailangan na lang natin siyang i-label. So, we can label this as F21. Tama, no? Dahil ito yung ating charge 1. Okay, well, the other one naman is F12. Tama? Tama po ba? Okay, so ganyan natin siya i-set up the F21 and F12. So, pwede na ba tayo makapag-solve? Yes, pwede na. Pag meron na tayong sketch na problem, nandiyan na lahat, ang nire-represent, okay, ng different variables, we can now solve, okay, the uh, problem itself. Okay? So let us try now to find the magnitude and direction of the electric force. The first one na tinatanong is the force that Q1 exerts on Q2. Okay, so ano yon? Anong part yun? The F12, tama? Because that is uh, the force that Q1 exerts on Q2. Take note of the word on Q2. Therefore, ang pinapahanap sa atin is F12. Okay? Or the force of 1 on 2. Parang ganun yung sinasabi niya dito. So, paano natin ngayon masosolve si F12? Nagamit tayo ng ating Coulombs Law. Okay, we have the K, okay, Q1, okay, Q2, divided by the separation distance of R1, 2. Tama, no? Tapos meron tayong square dito. Okay? So, just substitute the given values. Okay, so the K is around 9. K times 10 to the 9. Okay, hindi ko na ilalagay unit na kasi automatic naman na Newton ang ating result. And then you have here the absolute value of Q1 and Q2, the product. Okay, so ang binigay sa atin is nanocoulomb. Kailangan natin siyang i-transpose in terms of coulomb. So meron tayong 25 times 10, okay, to the negative 9. Pag in-input nyo siya sa calculator, dapat ganyan. Okay, in terms of coulomb, not in nano. Okay, and then you have multiplied by, dito ko na lang nilagay sa baba, negative 75, okay, times 10 to the negative 9. Okay, and take note that naka-absolute value yan. Okay, naka-absolute value. And then divided by the separation distance, which is 3 centimeters. Okay, so again, kailangan natin kunin yung SI unit, which is 0.03. Okay, kasi ang 30 centimeters, ang 3 centimeters is converted as 0.03 meters. Then, don't forget the square in the upper part. Okay, so yan na. I-plug in na lang natin sa ating calculator. Therefore, F12 is equivalent to what? So let's try to compute. This is 0.019 Newton. Okay, so that is the value of the force being exerted by 1 on 2. Okay, so 0.019 9, and it is an attractive force. Is that clear to everyone? Okay, so I hope that is clear. How about for B? If you will notice, in this part is that they just have the same distance, tama? So, parang mangyayari lang is babaliktarin mo lang itong part na ito. Ito. Yung Q1, Q2 magiging Q2, Q1 because that is the force Q2 exerts on 1. So, ganun pa rin naman i-multiply mo, right? Same distance pa rin naman sila. Therefore, kung ano yung value ng F12, okay, that is also the value of F21, right? Because they just lie in the same axis, having the same separation distance. Therefore, they will just experience equal in magnitude of electric forces, but opposite in direction. Okay? Therefore, hindi natin kailangan i-solve si F21 because F21 okay, is just equivalent to F12 okay, or just simply 0.019 Newton. Okay? So that is the answer for F21. Okay? 0.019 din yung kanyang value. Okay? So Newton's third law applies to this part okay, of electric forces. Even though the charges have different magnitudes, okay, the magnitude of the force that Q2 exerts on Q1 is as the same as magnitude of the force that Q1 exerts on Q2. Thus, these two forces occur in opposite directions. Okay, so I hope that is clear to everyone. So let us proceed in the other example. 2-point charges are located on the x-axis of a coordinate system. Okay, so you have here Q1, which is 1 nanocoulomb. Nasa coordinates daw siya na x is equal to 2 centimeter. Okay, so yung y na value niya is just 0. So, ang ordered pair natin dito is 2 cm and 0 cm. Okay? Because it is being specified here that the charges are located in the x-axis. Okay? Not in a two-dimensional plane. Okay? While Q2 is a negative 1, okay, na nasa 4 centimeter naman siya. Okay? Nasa 4 centimeter. What is the total electric force exerted by Q1 and Q2 on a charge Q3 na merong value na 5 nanocoulomb at x is equal to 0. Okay, so sa pagitan ni Q1 at Q2, okay, may nilagay daw na isang charge, okay, which is charge Q3. At ang kanyang location sa x-axis is nasa x is equal to 0 siya. Okay? So again, same setup. Ang kailangan natin gawin is i-sketch siya. Okay? Para mas ma-visualize natin. Okay, so gawa muna tayo ng ating axis. Okay, ating axis is the x-axis. Okay, this part, let's say that this is our x-axis. This is the center. This is the center of our x-axis. And then, sabi niya, si Q1 daw na 1 nanocoulomb is nasa 2 centimeter. Okay, so sabihin natin ito ay 1, ito ay 2. Okay, nandito siya. Let us just fill it with some colors. Order. Bring to front natin. Ganun talaga siya. Okay. Pwede na siguro yan. No? Yan yung ating Q1. Okay, labelan lang natin para hindi mahirap. Ito ang ating Q1. Nasa X is equal to 2 cm daw siya. Okay. While the other one, Q2 is 4 cm. Okay, so medyo malayo pala dapat, no? Kasi nasa 4 cm siya. Baliktarin na lang natin. Nandito si Q1. Yan. Yan, Q1. Sabihin natin ito ay 2 cm. Tapos, ilayo na lang natin to. Yan. So, 1, 2, 3, 4. Yan. Sabihin natin nandiyan siya. Ano. Yan. So, ito ang ating 2. Tama, no? Then, ating Q2. Tapos, meron daw Q3 na nasa x is equal to 0. Okay. So, duplicate natin. Ibig sabihin siya ay nasa origin. Okay. So, ito yung ating Q3. Ang tinatanong sa problem is that what is the total? Okay? Or the net, this part. What is the total electric force exerted by Q1 and Q2 on the charge 3 of this setup? So how do we deal with that kind of problem? Kanina, dalawa lang, di ba? Uh, this part, dalawa lang. Tapos ang hiningi lang sa atin dito is individual. Ngayon, dito sa specific problem na ito, isang hinihingi na sa atin is total electric force being exerted by Q1 and Q2 to this charge Q3. Okay, so yan yung ating pinaka-diagram. Ang next na kailangan natin gawin is labelan natin yung mga forces being experienced. So, ang ating pinaka-concern is the charge Q3. Ito, ang pinaka-concern natin. Alamin natin, yung mga electric force na kanya na-experience dahil kay Q1 and Q2. Dahil yun yung pinaka-concern, no? What is the total electric force? On a charge Q3. You are not concerned with the interaction of Q1 and Q2. Okay, because your frame of reference is Q3. Okay? Take note with that. You don't need to solve the electric force between Q1 and Q2 or Q2 to Q1, but rather the electric force between Q3 and Q1, Q3 and Q2. Okay, so I hope that is clear to uh, everyone else. Okay, so let us try to specify now the direction of electric forces. So si Q1, sabi natin siya ay, ano si Q1? Anong color ba maganda? Red. Sabi natin siya ay positive. Si Q2 siya ay negative. And si Q3 siya ay positive. Okay? With that kind of information, we would now be able to determine the electric forces being experienced by this Q3 due to this Q1 and Q2. Okay? So, tingnan muna natin yung kay Q3 at Q1. Pareho silang positive. Tama? Therefore, ang tendency is that si Q3 magre-repel siya kay Q1. Tama, no? So, magkakaroon siya ng repulsive force dahil sa presence ni Q1. Gusto niyang lumayo kay Q1. Okay, kaya maka-experience siya dito ng repulsive force. Okay, ganito ang kanyang direction. Tama? At pag nilabelan natin, it is labeled as F13. Tama, no? This is the force on 3 due to 1. Okay, absorb. Okay, plus, pareho sila. Q3 and Q1 are both positive, therefore they tend to repel. Okay, and the direction would be something like that. Our next concern now is the interaction of Q3 and Q2. Okay, because they are unlike charges, the tendency is that si Q3 gusto niya ma-attract kay Q2. Therefore, magkakaroon sila ng attractive force oriented in this direction. Okay, papunta siya dyan sa direction na yan. And we can label that as F23. Okay, ganun lang lagi. Kung sino yung concern charge mo, siya yung nasa dulo na subscript. Okay, hindi mo kailangan malito. F23. Ngayon, ang tinatanong sa atin is the total. Okay, total electric force. Therefore, we need to get the vector sum of F13 and F23. Tama, no? But before we get the vector sum of F13 and F23, kailangan alam muna natin yung magnitude ni F13 at ni F23 using Coulombs law. Okay, using the Coulombs law. So, F13 now, okay, is equivalent to K times the absolute value of Q1. Okay, and then you have Q3 divided by R sub 1, 3 quantity squared. Okay, don't forget that. And then just substitute the given values. For K, the 9. For Q1, nandiyan naman, 1 nanocoulomb. So, gagawin mo siyang 1 times 10 to the negative 9. Okay, so hindi ko na siya isusulat dito para hindi matagal, no? The value of F13, okay, solve nyo na lang sa calcu ninyo. Okay, para meron din kayong participation. Kasi pagka nood ka lang nanood, parang madali lang. Eh. Pero pagka ikaw na yung gumawa, medyo hindi pala siya madali. No? Kaya input nyo na lang yung values, hindi ko na siya isusulat. Okay. Ang kailangan natin ma-specify dito is the distance. Okay, we have the value of K, which is 9 times 10 to the 9. The Q1 to be 1 times 10 to the negative 9 coulomb. Our Q3 is 5 times 10 to the negative 9. Pero ano kaya yung kanilang distance? Okay, ano ba yung distance between Q3 and Q1? Okay? So, sabi natin kanina na si Q1, okay, kung maaalala natin, si Q1 ay nasa 2 cm of the x-axis from the center. While si Q2 naman ay nasa 4 cm away, okay, from the x-axis. And this is your x is equal to 0 cm. Okay, this is cm. Our problem here is this R13. So this R13 is the separation distance between 1 and 3, obviously. So ano kaya yung layo nila? So from the setup, we can clearly see that they are 2 centimeters apart. Tama, no? But you need to use an SI unit, kaya ang dapat mong gamitin sa separation distance is what? 0.020 meter. Okay, and then don't forget the, what we call this? Don't forget yung quantity squared. Yan. Okay. Plugging it now in the calculator, you would be able to find that your F13 is 1.12 times 10 to the negative 4 Newton. So that is the answer. Okay. Or you may just transpose it in terms of micro, right? Ano ba? Pwede natin i-transpose into micro. So it is also equivalent into 112 micronewton. Tama. Usog lang natin, magiging times 10 to the negative 6. Kaya magiging micro. It's either of the two answer is acceptable. Alright? So that is the value now of F13. Okay. Now, the question is, does the value of F23 the same to F13? Certainly not. Tama. Sa pag-sketch pa lang ng vector, hindi na sila pareho ng haba. Okay. Therefore, hindi siya pareho na 112 micronewton na kagaya na ito kanina. Okay. Hindi siya ganyan. Kasi, magkaiba na ng distance si Q3 kay Q2. Si Q3 at saka Q1 is 2 cm apart. But for this setup now, si Q3 at si Q2, they are 4 centimeters apart. Okay? That is why you have here F23 is equivalent now to K. So you have K multiplied by the absolute value of Q2, and then you have Q3 divided by uh, the separation distance R 2, 3 squared. So, ang gagamitin mo dito sa part na ito para kay R23 is 0.040 meters. Tama, no? Dahil yun yung layo ni Q3 kay Q2. Ito, 4 cm. This part. Ito. Yan, 4 cm ang layo ni Q3 kay Q2. Okay, so, ganun maggamit ng Coulombs Law. Kailangan mong alamin yung distance nung particular charge na concerned doon sa other charges malapit sa kanya. Okay, and then just plug it again in your calculator, the values. You must be able to find that your F23 is equivalent to what value? Okay, so the value is 0.084. O ba? Or 0.84. So let me compute. Okay, so I think that is just 0.84. Okay, times 10 to the negative 4 Newton. Or it is just equivalent also to 84 micro Newton. Okay, so these are now the magnitude of the individual forces F13 and F23. Okay, ngayon, ayan na ba yung final answer, sir? Hindi ba? No, kasi ang tinatanong sa atin dito, pansinin nyo, balikan nyo ulit yung problem. What is the total electric force? Okay, exerted, okay, by Q1 and Q2 on a charge Q3. Therefore, ang hinahanap sa atin is yung total. So, kailangan natin kunin yung total ni F13 at F23. The vector sum. Okay, vector sum. So, paano ngayon yung gagawin natin dyan, sir? Pansinin mo si F13. Si F13 is oriented to the left. Therefore, ang sign na kailangan mong gamitin is negative 1. Tama, no? Dapat siya ay negative. Si F23 ay positive kasi ang ating frame of reference ay si Q3. Okay, so pag in-sketch natin siya in different Cartesian plane, okay, nandito si Q3 mo, yan, siya yung concerned na charge, naka-experience siya ng attractive dahil kay Q2 at repulsive dahil kay Q1. Tama? Ganyan na yung pinaka uh, setup niya. Okay, so in order for you to get the vector sum of this, you need to specify the direction. So F13 is a negative value while the F23 is a positive value, right? Therefore, in order for us to find, okay, the F net or the total, it is equivalent now to the vector sum of F13, okay, plus F2 F23. Okay, whereas our F13 has a value of, ito na lang gamitin natin para mas madali, ay 112. 112 Newton, but it must be negative 1. Tama, no? It must be a negative value. Negative 112 micro Newton. Okay, dahil nga sa ating diagram, siya na ay oriented in this part. Okay? So, maging maingat sa pagkuha ng vector sum. You need to specify the direction. Okay? That is why you have negative 112 Newton plus this F23 now is a positive value dahil siya ay oriented to the right. Okay, itong part na to. Which is 84 micro Newton. That's why you need to write it 84 micro Newton. So what then is the value of this? The F net now, okay, so the F net now is equivalent to what? So negative 112 minus plus 84 is negative 28 micronewton. Okay, so that is negative 28 uh, Newton. So what does it mean? It means that the charge, okay, the charge Q3 in the origin of the x-axis experiences a net force na ganito. Okay. Yung kaninang dalawa, ito yung nasa upper right, left. Okay. Pag kinuha na natin yung vector sum niya is ganito na lang yung kanyang itsura. Okay, so this is now the F net being experienced by that charge Q3 due to the presence of charge Q1 and Q2. Is that clear to everyone? So I hope that is clear. So let me just give the last example. Okay, two equal positive charges Q1 and Q2. So dito equal ang ating charge. Ang value daw is 2 microcoulomb. So times 10 to the negative 6. Are located at x is equal to 0, y is equal to 0.30, and x is equal to 0, y is negative 0.30 respectively. Okay, so itong ordered pairs na to or coordinates na to para kay Q1. Okay, at ito namang coordinates na to ay para kay Q2. Okay, ganun yung ibig sabihin na itong respectively. So what are the magnitude and direction of the total electric force that Q1 and Q2 exert on the third charge Q? Okay, so may third charge na naman dito. Ang kinaibahan nito sa previous example is that this is now a two-dimensional case problem. Okay, unlike the previous one na nasa X lang. Kasi meron na tayong coordinates or ordered pairs sa X and Y. Okay, so ano daw yung total electric force na mai-experience nung charge Q na malaki dahil sa presence ni Q1 and Q2. At si charge Q na malaki ay nandito sa coordinates na ito. 0.40 meters and y is equal to 0. Okay, so kailangan nating mag-sketch ng ating problem. So gawa tayo ng two-dimensional Cartesian plane. Okay, so this is our two-dimensional plane. You have the y-axis and then you have the x-axis. And then ilocate natin yung mga charges. Okay, si charge Q1 daw ay nasa 0.3 meters. So sabihin natin nandito yan. Ayan. Okay, yan si ating charge Q1. Si charge Q2 naman, nandun din pero sa opposite direction. Okay, nandito siya. Ayan. Okay, so alam natin that this distance, okay, this part, and this part are just equivalent. Okay, ang value lang nila pareho is 0.30 meters. Okay, yan, 0.30 meters and 0.30 meters. Sir, bakit nandiyan dyan sa part na yan? Kasi nga ang x natin doon is 0. Okay, so yung 0 at 0.30 ay nandito sa point na ito. And at the same time, dito rin sa point na ito. Ngayon, meron daw isang pa-epal na third charge Q. No? So, I forgot to label. This is your charge Q1. Okay. Natin lagay. Dito na lang, no? And this is charge Q1 and this would be your charge Q2. Yan, charge Q2. And then, meron daw umepal na isang third charge na nasa 0.40 meters. Okay, so kung 0.3 ito, siguro nandito yan. Yan. Palitan natin ng kulay para yan. Ang ating concern na pagkukuhanan ng net force ay C red. That's green. Yan. Ito ang ating concern ngayon, si charge Q. Okay, gusto nating alamin yung net force na na-experience ni capital charge Q dahil sa presence netong Q1 and Q2. Okay? So, we forgot the distance here to be 0.4. 0.40 meters. Okay, yan yung kanyang layo. Okay? I hope that is clear to everyone sa atin. So what then is next? Ano na ngayon ang next? Ang next thing na kailangan nating alamin is yung direction ng forces. Tama? Si Q na, na capital, meron siya na-experience na electric force dahil kay Q1 na malapit sa kanya at si Q2 sa presence ni Q2, right? So, kailangan nating i-sketch yun. So, paano natin kukunin? Dahil kay Q1, siya ay positive. Okay? Si Q2 ay parehong positive. Okay? At si Q3 rin naman ay positive, 4 microcoulomb. So, lahat sila ay repulsive. Okay? Therefore, this Q will experience a repulsive force oriented into this direction. Tama, no? Ganyan siya dapat. Kasi pagka inan natin siya, yan yung ating line of axis, something ganyan. This charge Q must experience a repulsive force oriented into this direction. Same thing with here. Okay, meron siyang ganyang repulsive force. Tama, no? Ganyan yung kanya na-experience. And then we can just label it out. Okay, this force is what? F2Q. Yan, sabihin natin F2Q. Okay? How about the other one? This is F1Q because that is the force of 1 on Q or the force on Q due to 1 and this is the force on Q due to 2. Tama, no? Ganyan yung ating setup. Okay? So, how to find then the uh, net? Kailangan alam muna natin itong F2Q at F1Q using Coulombs Law. Okay? Pero hindi ka makakapag-proceed sa Coulombs Law hanggat hindi mo alam yung layo ni Q1 kay Q at ni Q2 kay Q. Okay, so paano mo ngayon malalaman yung layo neto? Okay, at layo neto. Kailangan mo gumamit ng Pythagorean theorem na tinatawag. Tama, no? So, using the Pythagorean theorem, so what is the value then of that side? Okay, so you have here 0.30, 0.40. This is something to do with the hypotenuse. Okay, so what is the distance of that? So that is around 0.50 meters actually. Okay, so that is the distance na kailangan mong gamitin doon sa iyong Coulombs law. Okay? And at the same time, you will notice that F1Q, okay, you will notice here that F1Q is actually equivalent to F2Q. Tama ba? Dahil pareho naman sila ng distance. Okay? Pareho rin naman ng magnitudes, yung Q1 and Q2. Okay, therefore, yung masosolve mo na F1Q is also the same to F2Q. So, paano mo masosolve yung part na yan? Use Coulombs law para makuha mo yung values na yan. Okay, yan yung kailangan mong gamitin. Coulombs law. Tama? And then afterwards, pag nakuha mo na yan, you would now be able to find the net, okay, electric force in this setup. Okay? You can now get the electric force on this charge Q due to this charge Q1 and charge Q2. Okay, so together with the other problem a while ago to find the Q, okay, this is also a working task lang sa inyo. Okay, use the component method of vectors to find the net force. Okay, find the net force on Q. Okay, so do it in a piece of paper na malinis. Okay, ito kanina yung pinapahanap. Okay, solve for this Q and this part. Okay, find the net. Itutuloy nyo na lang to. Okay, solve nyo yung F1Q and F2Q using Coulombs law. and then vector addition na tayo, component method to find f net on Q. Alright, so I hope that is clear to everyone. Thank you very much, and I hope you have learned how to use the Coulombs law.